Hi guys, today we're going to be going through the carboxylic acid notes. So this will be lesson 5.6. Now, carboxylic acids, these are organic acids. So, we normally think about acids as being able to release an H plus when they dissociate, like something like hydrochloric acid, which would be HCl. But carboxylic acids, are characterized by the radical group COOH. So the general formula R-COOH. So this is called a carboxyl group. So R would be the main chain. And so if we were to draw it out, it would look like this. You'd have a double bonded oxygen and then a single bonded hydroxyl group, okay? So this right here is called a carboxyl group, okay? So carboxyl group, that's what it is with the COOH. We just abbreviate it COOH in notes often as a way of writing it a little quicker, okay? Now, when we name carboxylic acids, you're going to drop the E and add the suffix oic to the name of the parent hydrocarbon. And then the name is followed by the word acid. So, for example, so here I've drawn the structure for you as well as written how it would look typed out. So the structure here, we've got one carbon, right? And I know it's a carboxylic acid because it's got this carboxyl group here. And then this middle carbon here, it's got 3 bonds, right? 2 to the double bond oxygen, 1 to the hydroxyl group. And so we have room for 1 hydrogen here. So if you were to write that out, type it out, you may see it represented as HCOOH. And so the name of this, we're going to look at the alkane it would be. So this would be methane, right? So if we follow the rules here, we've got methane, and it says drop the E. So let's erase that E. So take off the E and change it to oic acid. So the name of this particular carboxylic acid is methanoic acid here. So 1 carbon, prefix meth for that. Okay, let's go through this next example here. Now this is the one you've got in your notes here, drawn like this. I just wanted to show you a different representation, and this is what we're going to be doing in class when you get back. We're going to be looking at the Lego structures, essentially, right, of building molecules. So it would look something like this, where the yellow are the hydrogens, the pink ones here are the oxygens, and the blue are the carbon. Now, looking at this, I've got 2 carbons. Now, incidentally, just so you know, the numbering always is going to start from here. So by definition, but that's a rule, it always starts with the first carbon that's in the carboxyl group here. So I've got 2 carbons here, so the prefix for 2 is eth. So instead of ethane, we're going to call this ethanoic acid. And ethanoic acid, that's also known as acetic acid, and that's what's in vinegar, okay? Good. Next, we've got this one. So again, I'm just showing you different representations of this. I think I missed one. Sorry, guys. I missed... hold on. 1, 2, 3, 4. Oh, shoot. What did I do? 1, 2, 3, 4. 1, 2. Oh, this is the wrong one. You know what? Take one of these carbons out here. This is wrong. No, I totally... Yeah, sorry. It's fine. I missed propanoic acid here, so let's just... I don't have a blank slide here to do this on. Let's do it here. Hold on 1 second. Oh, that's not what I wanted. Okay, let me just erase this. I'm going to draw out propanoic acid because I missed that. So propanoic acid is just going to be this one here. You can also see it written as CH3, which is here, CH2, which is this one, and then whoops, I'm not sure what's going on here, C, and there we go. That would be another way of writing this, and this is called, instead of propane, of course, this would be propanoic acid. Okay, sorry about that, guys. Okay, next, So this then, these are all different ways of showing butanoic acid. So butanoic being 4 carbons in a row, right? So I've got 1, 2, 3, 4. If you're writing it on a page, you'll probably write it like this. This would be the molecular model kit for this. And then you'll also see these line graphs, or pictures, I should say. And now, of course, this is drawn backwards. So we've got the carboxyl group on the left. There's nothing that says it has to be on the right. It can be on the left. That's completely fine. And then every point is going to be a carbon here. So you're going to have 1, 2, 3, 4 carbons, and that would be where we get our butanoic acid from. So just be aware that sometimes you'll see these. I'm not going to use those. I'm not going to put them on any of your assessments, but I want you to be aware that that's often how they're represented. Okay, and this, of course, is the same thing, so we're not going to, oh yeah, this one, sorry, it is a little different. Now we've got a radical, okay? So if we look here, we've got our carboxyl group here, but then we've also got a radical. And so we're going to name these just like how we've always named things with radicals. But again, the thing to remember is that the numbering always starts from the carbon that's in the carboxyl group, okay? So 1, 2, 3, 4. So the name of this then, 3-methyl, and then dash, and then in your notes it's missing one. Technically you should have a 1 in there. So 1-butanoic acid. Okay, if you leave out the 1, it's okay, but I think we should put it in just to be consistent here. All right, sound good? Okay, so again, these are pretty straightforward. You can do worksheet 4, part number 2. I don't think there are many questions for that, and you have the answer key already for that. Okay, thanks everyone.